You're welcome to GMMB Academy. We are looking at this topic in mathematics, variation. Meanwhile, you should know that in GMMB Academy, we have a lot of teachers teaching maybe a course on or a subject, I mean to say. Now, today, Professor Dare Samson will be taking you on variation. Now, I want to welcome to the board Professor Dare Samson. You're welcome, sir. You're welcome. Thank you, sir.
All right. Good afternoon. We are going to be looking at variation. Variation. We are going to be looking at variation. Under this variation, what are those things we look into? They are introduction of variation and types of variation. Then we also need to look into the mathematical approach and expression while applying that of the variation. Now, what do we understand by variation? Variation is a concept that shows the relationship between two or more variables. Is a concept that shows the relationship between two or more variables. Between two or more variables. Now, when we talk about variables, the variables can be in form of real number, it can be in form of letter or alphabet, or it can be in form of integers. Anything that's the real numbers. For instance, like y, x, z. So these are variables. These are variables. Now, when we talk about the relationship between that of between the two or more variables, we are looking at how they relate, the interaction of the variables. Now, let me use this as a case study. But before that, we can also say that variation is a function of the variables. Is the function of variable. For instance, where we have something like this, y equals to fx. Now, when we talk about the head there, the head is just like the constant there, the constant. Now, so this is the verb, that is y and that of the x. So, when we talk about variation, variation can also be known or defined as a function of a given variable, which shows the relationship between the variables. Now, looking at that, we have types of variation. Before I go to that type of variation, I love to give an application that is in terms of a real life situation, because some students might think, why are we doing mathematics, or why are we using this, or what's the essence of variation. Now let's look at this. For instance, now look at this scenario where we have a young man and a young lady that are into a relationship. Now, for them to be into a relationship, that means the aim of the relationship is for them to get married. But in some cases, when they are already into that relationship, the young man might not be in that direction for the marriage. It might be something else, just to be with that young lady. Then you have someone else that he or she wants to marry. So now, that's it. So that means that they are not going in the same direction. So we are looking at the relationship between that of the young man and the young lady. And for them to come together, so they have an objective for what? Which is to get what? Married. Now, we have types of variation. Now, looking at that of the illustration of variation. Now let's look at this. Where we have y equals to 2x. Now I said that variation is to show relationship between two or more variables. Now look at this 2 now. This 2 is not represent that of the f there, represents the 2, which is fixed. Now, if we look at this, now this one is called independent variable. It's called independent variable. While this is called dependent variable. So this is called independent variable. Why this is called what? Dependent variable. This is called a dependent variable because this is depending on this. Because why would we say that the x is depending on this? Because once x is 1, so definitely this will be what? 2 bracket 1, which give me what? 2. If we are given that x equals to 3, it means that the variable here will be what? 6. That is 2, open bracket this, that is 2 times 3, there I have 6. So that is why the variable x is depending on this. It's depending on this. So that is why it is called dependent variable. But y is known as the independent variable because it's not depending on anything here. So now, that one by the way. So now let's go straight to types of variation. Types of variation. Types of variation. Now we have 4 types of variation. We have 4 types of variation. Now what are the 4 types of variation we have? We have the first one, we have the direct variation. Then the second one, we have indirect variation, or we call it inverse, variation. Then the third one, we have the joint variation. Alright. The fourth one we have is the partial variation. Now, we are going to look at it. I'm going to explain all these types of variation. The first one is direct variation, we have indirect variation, then we have joint variation and partial variation. Now let's look at this direct variation. What do we understand by direct variation? Direct variation is a situation whereby the variables, that is, the two variables are going in the same direction, whereby the two variables are going towards the same direction. So that means as the variable is increasing, that is the variable, one of the variables is increasing, then the other one is also increasing. That is, they are going in the same direction. If the variable is decreasing, the other variable will also be decreasing. What are we saying? That is, if the variable of y is increasing, then the variable of x will also what? Increase. If the variable of y is decreasing, that is coming down, is falling, then the variable of x is also what? Coming down, is dropping. That is, it's falling, it's decreasing. Now, that is, they are going in the same direction. So that is why if you look at illustrating your supply, you see it's a positive because they are going towards the same direction. Okay, that's not what we are doing here. Now, direct variation is to show the relationship of the two variables going towards the same direction. That is what we mean by direct variation. Now, let's look at this illustration. The illustration here is that when we have x is directly proportional to y. That is, x is directly proportional to y. Now, in this scenario, now you see a question like this, you should know that this type of variation is direct variation. Why? Because it said it is directly proportional, so it is direct variation. Now, how do I approach this in terms of mathematical expression? This is a word problem. So the interpretation of this is that x varies directly, that is directly proportional or very directly proportional to what? To y. That is, what we are saying now, this is the sign of variation. That's the sign of variation. So don't bother about the sign there. So now, that means that the x, this sign will now turn to what? Equal sign. Now that if you turn to equal sign equals to y. What are we saying? We are telling this is telling us that x is equal to y. That is, they are going to say that. So whatever value is given, whatever value that is here is equivalent to what is there. That is the same with what should be here. Now, if this place is 4, this place should also be what? 4. If this place is 5, it should be what? 5. Because they are going in the same direction, the same aim. Just like what I said earlier before. The young man and the young lady, they are into a relationship with the aim that with the same objective is for them to get married. That is direct variation. That is direct variation. Now, in terms of this direct variation, there's something you need to understand. There's what we call constant. There's what we call constant. And why do we include constant? There are some cases whereby, alright, that is, they should be going in the same direction, or the other should be going to the opposite direction. But in other scenario, in some cases, they might not go the same direction, while the same person still remain the same position. For instance, where we are going to introduce what we call constant. Constant. Now, the constant is referring to what? The k. Now, k, which is the constant. Why do we have constant? Why applying this direct variation? In every situation, in variation, you must introduce your constant. You must derive your constant. Why? Is because, you know, we talk about, we say that variation is you are going the same direction or you are going opposite direction. There are some cases whereby you are going towards this direction and the person is not going opposite, is not following you, but you still remain at that same position. What am I saying? For instance, now, maybe you and your friend are going somewhere and the person decided that let's go towards this side or to the right place, and is heading to the right, and the person said, no, I'm not going to the right, I'm not going to the left, I'm going to stay at that spot. That is the constant there. So the person might decide not to give you the result or the decision or whatever he wants to do. He might just decide to stay. Just for instance, maybe you ask someone a question, either yes or no. Not yes, not no. No, the person didn't answer any of it by not answering the question. Not yes, not no, because you could not get the results or the response of such person. So he still remain at that same position. So it remains constant. So we need to introduce our constant because there are some cases whereby the person might not decide to follow you towards that direction. It might remain at that same spot. So we introduce our k. So that's why we now introduce our k by saying that x is equals to k1. X equals to k1. So now what do I do here? Look at what I did. Very simple. They say x is directly proportional to y. Good. Now this is what we do. This is the mathematical expression of the mathematical approach. X is directly proportional. This is the sign of directly proportional or very directly proportional to what? Y. Then this sign now turns to what? Equal sign. X equals to y. Now after that, you need to introduce your constant. Why? Because the constant remain at that same spot. That's the meaning. That is, it does not change. It does not vary. It does not change. It does not vary. So you need to introduce it. That is x equals to what? K1. X equals to K1. So this is now the relationship of this illustration, of this question, of this word problem. X is proportional, is directly proportional to y. X equals to K1. Now let's go to indirect variation. Indirect variation is whereby the variables are not going in the same direction. They go opposite direction. Maybe the variable of y is going up, is increasing, while the variable of x is decreasing. So they go the opposite side. That is, they are not going in the same direction. That is, they are going in an opposite direction. So the other one is increasing while the other one is decreasing, or the other one is decreasing, the other one is what? Increasing. So that is what we are saying. Now, how do we approach this in terms of this? So let me use this illustration where we have z is that z varies inversely proportional to y. Z varies inversely proportional to y. So the first thing you need to know is that you should need to identify what type of variation is this. In this case, this is called indirect variation. Indirect variation, or you call it inverse variation. Now, how do I approach this? How do I express this? This is a word problem. So I need to put a mathematical expression. How do I do that? Now, I'll now put it by saying that z varies, this is the sign of varies or variation, proportional to y. Proportional to y, that means they are not going in the same direction, that's opposite of it. So this will now become 1 over 1. Why is it 1 over 1? So because I said inverse, so the inverse, because we want inverse or indirect, so you need to look for the inverse of y. You need to look for the inverse of y. So what is the inverse of y? The inverse of y is 1 over y. For instance, you know that this is y. This y is just like y over 1. So this, that is just like a reciprocal or the inverse of this. So this goes up, y this what comes down. That is, this will go up, y the y will come down. That's what they are saying about the inverse. So if they ask you what is the inverse of 3 over 2, for instance, the inverse of 3 over 2 is that the 2 comes up, while the 3 comes down, which is what? 2 over 3. That is the inverse of this question. Now, because it said z varies inversely proportional to y. why is it that this one is 1 over y? Because this y is y over 1. Y over 1 is the same thing as y equals 1. So there's y over 1 there. So by forming it in form of fraction, so this will now be the reciprocal of y over 1, which is 1 over 1. So now z varies inversely proportional to y. Z varies inversely proportional to y. So this z varies proportional. That is, z varies inversely proportional. What? To y. So the inverse of y, which is what? 1 over 1. Now you have done that, then we now say that z is equals to 1 over 1. This sign is now turns to what? Equal sign. That is, z equals to 1 over 1. Then you need to introduce a constant. I told you that before that anytime you have to variation, you need to introduce a constant. So now z will now equals to k 1 over 1. Now this is my constant. This is my constant now. So then what will I do next? So I can now say that z equals to k times 1 is going to be k over 1. So this is now the relationship or the interpretation of this word problem. This is the interpretation of this word problem. Now this is the word problem, then you form it in form of mathematical approach or mathematical expression. This is it. Now, that one by the way. Then we look into joint variation. Joint variation is the type of variation where you combine both the direct and that of indirect together. When there's a combination of direct and indirect variation, that's what we mean by joint. You combine the two variation, which are the direct variation and that of the indirect variation. That's what we mean by joint variation. Now let's look at this illustration. Let's look at this illustration where we have something like this. We have something like this. Please let me clean this up. Now, looking at this, where we have x varies directly to y and inversely proportional to z. X varies directly to y and inversely proportional to z. Now, how do I solve this? This is now a word problem. Now we want to apply it using the mathematical approach or the mathematical expression. You are applying this is the word problem. So now how do I treat that? Now the first thing you need to know is you need to identify what type of variation is this. What type of variation is this? As you can see, that this type of variation is this. As you can see in this illustration, this question, this is joint variation. Joint variation. Joint variation. Where we have, you can see the combination there, directly and that of the inversely or indirectly. So this is joint variation. So I can now say that x varies directly to y, and that same x also varies inversely. That is inversely proportional to z. That means the inverse of z. What is the inverse of z? Which is what? 1 over z. Can you see that? X varies directly to y and inversely proportional to z. So that is the inverse of z, which is 1 over z. Alright. Now, what's the next thing to do? So I can then say that x equals to y 1 over z. So the same thing. Now, the next thing now is x now equals to, you multiply this y times 1, we have y over z. Y over z. Y over z. Now, this is now a joint variation. Now, we need to include our constant. Now, how do I include my constant now? So, I will now say that x, you know that x equals to y over z. x equals to y over z. Now I'm going to include my constants. So by constant there will now be x equals to k y over z. I hope you understand that. Alright, now which is x equals to k, that's the constant. We have y over z. This is y over z, see there. Now x will now equals to k times y, we will want k y over z. So this is the relationship of the mathematical expression of this work problem of the variation. We all know that this is a joint variation, and this is now the expression, the mathematical expression of this joint variation. So from there we will continue from there next class. So I'm going to stop here. So next time we are going to solve more questions. We are going to solve questions on this. I'm just explaining the approach, how to approach it and how to express it. So the next class we are going to look at the calculation on variation. So if you have any question you want to ask, you can put it on the comment box, and may God bless you.
Alright, thank you, sir. Thank you, sir. Alright, so Professor asked you to drop your comments, your questions on the comment sections. He's always there to attend to you. So you won't want to miss the next class, which is going to be calculation purely on variation. So, and we want to see you in that class. See you soon. Bye for now.